Hi, folks. Today, our next polynomial skill is going to be factoring polynomials, particularly polynomials of the form x squared plus bx plus c. Notice in this format, what we're learning today, the coefficient on that x squared term is 1. We don't have other coefficients yet. We'll learn how to do that in the next lesson. When you're evaluating how to factor these kinds of polynomials, the thing that's really going to come into play is paying attention to whether B is positive or negative and whether C is positive or negative. And you can kind of see from this flow chart here that there are going to be three possibilities. Either both B and C are positive, or C is positive and B is negative, or C is negative. So let's look at each of these kinds of examples in turn and see how to handle these. First, let's look at where B is positive and C is positive. So this is positive 10x and positive 16. The first step in doing this is identifying what B is, B equals 10, and identifying what C is, C equals 16. Because we're going to be talking about factors that multiply to a certain number. Factors, when you add them together, you get a certain number, and we need to know which number B is and which number C is. And what we need to do is find the right value of P and Q so that P times Q equals C, equals, in this case, the 16, and that P plus Q equals B, the 10 term. So what I can do is just start making a list of factors of 16. So 1 times 16 is 16. 2 times 8 is 16. 4 times 4 is 16. So those are all the factors of 16 paired up by what they need to be multiplied by. And now let's look at what happens when we add those factors together. 1 plus 16 is 17. 2 plus 8 is 10. 4 plus 4 is 8. So notice I get my biggest number here when I use my biggest sum when I use 1 and the number itself. So if I have a really big sum in the middle, I would want to use those extreme factors of C. If I have a smaller B value in the middle of my polynomial, then I would want to choose factors that are similar to each other, like 4 and 4. Here you can see that the pair of factors that add to 10 are 2 and 8, and so those are the factors I want to use as I factor this polynomial. So I'm going to write this as x plus 2 times x plus 8, and this should be correctly factored now. Of course, I don't have to guess that it's correctly factored. I can check that it's correctly factored by going ahead and checking using FOIL, using the distributive property. And when I multiply x times x, I get x squared. X times 8 is 8x. 2 times x is 2x, and then 2 times 8 is 16. And of course, 8x plus 2x add up to 10x. So the FOIL does check out. My answer, my factoring is correct, and I'm finished with the problem. Let's do an example where B is negative and C is positive. So if my B value here is negative, B is negative 8, and my C value is positive, C equals 12, we're really doing the same strategy here. It's just that this time my P and Q values are both going to be negative. Two negatives, when I multiply them together, is going to create a positive. And then when I add those two negatives together, I'm going to get a negative number. So I'm still doing the same strategy. I'm still thinking about what numbers could multiply together to get 12, like 1 times 12. Except this time, my 1 and my 12 both need to be negative. They both need to be negative because when I add them together, I need them to be a negative number. So negative 1 times 12, negative 2 times negative 6, negative 3 times negative 4. And once you get to where the numbers are the same or one away from each other, you know there aren't any more factors if you're being systematic about listing them. And I was increasing um, just kind of step by step my first factor of C. My sum of factors. Negative 1 plus negative 12 is negative 13. Negative 2 plus negative 6 is negative 8. Negative 3 plus negative 4 is negative 7. Again, notice when my factors are closer together in value, my sum is smaller than my extreme values of my extreme factor values. The sum that checks out is that negative 8. So these factors are the ones I'm going to use in my in parentheses. So I'm going to have x minus 2 times x minus 6. Again, we should do FOIL to check to make sure that our factorization is correct. X times x is x squared. X times negative 6 is negative 6x. Negative 2 times x is negative 2x. And negative 2 times negative 6 is positive 12. And when you combine negative x, 6x, and negative 2x, that equals negative 8x. So this does check out. And so we know that we factored this polynomial correctly. So what do we do when C is negative? When C is negative, then one of the factors needs to be positive and one of the factors needs to be negative. One needs to have an addition sign, one needs to have a subtraction sign. Because that's the only way you can get a negative number is by multiplying together a positive and a negative. So we're going to choose a p-value and a q-value so that p times q equals C, but our p and our q are going to have different signs. So what are the factors of 21? Negative 21, excuse me, negative 21. We need to get that negative number. So we could multiply negative 1 times 21, or we could multiply positive 1 times negative 21. Both of those are possibilities. 21 is not divisible by 2, but it is divisible by 3. I could have negative 3 times 7, or I could have positive 3 times negative 7. Notice that I'm needing to list twice as many factors here because it's not just the number that matters, it's the sign that matters. And when I have one negative sign, I could either put it on the first number or the second number. I've run out of factors for 21 here, so there aren't any more to list. I just have these 4. And when I add the factors together, negative 1 plus 21 is 20. 1 plus negative 21 is negative 20. Negative 3 plus 7 is 4. 3 plus negative 7 is negative 4. Look at those relationships there. When I put the negative sign on the big number, my b value is negative. When I put my negative sign on the smaller number, my b value is positive. So keeping that in mind, keep that in mind in future, that you maybe don't have to list every single possible combination of factors. You can look at that b value and decide, hey, that b is positive, so I want to make sure I put my negative on the small number so that the bigger number, the positive number, wins when you combine terms. So positive 4 was my middle b value there. So this is the combination of factors I want to use. So I'm going to have x minus 3 and x plus 7. Once again, we should check to make sure that this checks out. So I have x squared from multiplying those first terms and do outside. Um, x times 7 is 7x. Then do those inner terms. X times -3 is -3x. -3 plus 7 is, I'm sorry, -3 times 7 is -21. And when we can combine those middle terms, 7x minus 3x is positive 4x. And so this does check out. And we factored this one correctly. So just to kind of put in writing what I just said verbally, when C is negative, uh, one of your factors is going to be negative, one's going to be positive. So look at B. If B is positive, put the negative sign on the smaller factor. So the positive wins out because the positive is on the large factor. On the other hand, if B is negative, put the negative sign on the larger factor so that the negative value kind of overpowers the positive value. And this strategy works so long as the x squared has a coefficient of 1. So if we look up here, there are a couple factors we could have skipped testing. We didn't really need to test this one because this was always going to give us a negative number. We didn't really need to test this one because this one was always going to give us a negative number for b. Okay. Another one that as you get used to doing these problems that you might skip testing is when you have such a small value of for b here, you're probably not going to be testing these extreme factors because the sum is so large. And so we wanted a smaller b value. And so testing factors that are closer together, um, testing those first will get you to the answer more quickly. Let's look at a real world problem where you might use this kind of factoring method. So a farmer plants a rectangular strawberry field here in the corner of a square plot of land. And I don't know how long each side of this square plot of land is, but we're calling the side length S. And this strawberry patch is 600 square meters. So this part right here is 600 square meters. And I don't know the exact dimensions of the strawberry patch, but I do know that there's 30 meters left over here on the bottom of this square patch, and there's 40 meters left over here on the side of the square patch. So I can think of this side of the strawberry patch as being S minus 30 meters. And I can think of this side of the square strawberry patch, I'm sorry, the rectangular strawberry patch as being S minus 40 meters. And whatever S minus 30 times S minus 40 is, that equals 600. So I can solve for S. I can figure out how big how long each side of the strawberry patch is by solving for S. Well, we know how to solve polynomials, but it involves setting the polynomial equal to 0. And right now my polynomial is not equal to 0. It's got a 600 on it. So I need to move the 600 over to one side of the equation. But then I need to combine it with my polynomial. So what I really need to do is multiply out my polynomial first, kind of writing this in standard form. And then I can subtract the 600. So let's start with this. I'm just going to use FOIL. S times S is S squared. S times negative 40 is negative 40S. S times negative 30 is negative 30S. And negative 30 times negative 40 is positive 1,200. This whole thing is still equal to 600. All I did was expand, um, uh, simplify this multiplication of polynomials here. I'm going to simplify even more what I have written here because I can combine those like terms. So that leaves me with s squared minus 70s plus 1200 equals 600. And now I can work on getting 0 on one side of the equation by subtracting the 600, subtracting the 600, and I get s squared minus 70s equals, I'm sorry, not equals yet, plus 600 equals 0. Now, if I want to solve this, remember the trick for solving polynomials is to use the 0 property feature. Anything, if you have a multiplication problem equal to 0, one component of that multiplication problem must be equal to 0. So I need to turn this polynomial into a multiplication problem, just like we've been doing in the previous examples. How do I turn this into a multiplication problem? I need to think of the factors of 600. And because my b value here is negative, both of my factors are going to be negative. Now, 600 has a whole lot of factors. I am not going to sit here and test every possible factor of 600. What you might consider doing is kind of testing like 1 and 600, or I'm sorry, -1 and negative 600 as the factors. That's going to add up to negative 601. That's very big. So I don't need to test 2 times 300 or 3 times 200. Those are still very close together. I'm going to skip several. Let's just do 10. Let's skip up and do 10. Negative 10 times what equals 600? That's negative 10 times negative 60. And so if this ends up being too small of a number in the middle, then I know I can go test some number between 1 and 10 in terms of the factors. Okay, so I'm looking at this, and negative 10 plus negative 60 is actually negative 70. So I've hit on the right combination of factors here that's going to add up to negative 70. So when I factorize this, I'll have s minus 10 and s minus 60 equals 100. Just to double check this for a moment using FOIL, let me just scooch over here. S times s is s squared. S times negative 60 is negative 60s. S times negative 10 is negative 10s. And negative 10 times negative 60 is positive 600. And yes, negative 10s minus 10s, I'm sorry, negative 60s minus 10s adds up to negative 70s. So this checks out. I know I've factored it correctly. I factored it correctly, but that wasn't what the problem asked me to do. The problem asked me to solve for the area of the square plot of land. So I need to figure out what the side length is. I need to actually solve for s. So because I have a multiplication problem set equal to 0, s minus 10 might equal 0, or s minus 60 might equal 0. Either one of those would make this a true statement. So either s can be, let's say if I add 10 to both sides of the equation, either s equals 10, or if I add 60 to both sides of this equation, s equals 60. So either the side length of the square is 10 meters or 60 meters. So which one is it? It can't be both. Sometimes you're not given enough information to really fully be able to solve the problem when you're left with two answers like this. But in this case, we definitely can solve the problem. In this case, it is not possible for my square to be 10 meters wide because if it were, I couldn't have 30 meters left over after subtracting away the strawberry patch. So the side of the square must be much bigger than 10. And so 10 does not make sense, and 60 is the only number in this problem that makes sense. We actually still haven't fully answered the question yet. We're asked, what is the area of this square plot of land? And for a square, the area equals the length times the width. Of course, the length and the width are the same thing, so you can think of it as just being the length squared. In this example, we're doing the side squared, and the side is 60. So 60 squared, if you multiply that out, is just 3,600 square meters. So this is an example of how you can use um, factoring polynomials to solve problems that you might actually want answers to. I hope this helped.